Okay, so we're back on page 461 and we are ready to do example number 6. Example number 6 says find the magnitude and direction of each of the vectors. So A, my vector U is 3, 2. 3, 2. So the magnitude of U, not U, is going to be square root of 9 plus 4, square root of 13. That was simple enough. The angle, which is that, so it's 3 and 2, right? So 3 and 2 would be like that. So they're looking for this angle here. So the way you found this is that tangent of theta is going to be this over this. So it's going to be 2 over 3, right? Whatever you have here divided by that. Okay, so you have to do the arctangent thingy, right? Arctangent. And it's going to be less than 45. What does the book say? It's 33.69. Okay. B, -2, -5. I have -2, -5. So the magnitude of this is going to be 4 plus 25, square root of 29. The tangent of theta is going to be this guy divided by this guy, 2.5. Okay. So if you do the arctangent of this, you are not going to find the angle. Right? If you do the arctangent, because tangent is positive, it's going to give you a degree in the first quadrant, but this guy lies in the third quadrant, right? Because it's a minus and minus, right? So you have to add 180 to whatever you find. Okay. Remember, the calculator is only as smart as the user.
I'm not that smart.
Okay. So if you do the arctangent of 2.5, Hunter is doing that for us right now, as you speak. What do we get?
My calculator's not set up, so someone else do it.
Calculator's
Make sure you're in degrees.
Yeah.
Make sure you're in degrees.
I'm getting there.
68.2.
Plus.
So you have to add the 180. Then you get 248.2. Okay? Right? We good?
It seems like such a pain to do this, man.
Yeah, what you're saying is using your brain is a pain.
Yeah, actually, yes.
So you would rather live your life
No,
mindlessly.
not really, but today I'm pretty,
Oh, just
tired.
today.
I'm pretty,
You must be hungry.
Yep. I can't work until I eat.
I'm pretty hungry too.
Okay, example number 7. A DC-10 jet aircraft is flying in a bearing of, oh, here we go. Bearing, whenever you hear that word, ding, 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 careful with the angle, right? Because the bearing always starts from due north, right? This is a bearing of 0, and I'm going 65 degrees from there. So this guy here is 65 degrees. And we are 500 miles per hour. Okay, so that is my magnitude. Find the component form of the velocity of the airplane. So in other words, so this guy here is going to be what?
20.
25, not 20, 25.
I was getting to the 5.
Okay, we're getting to the 5. So it's going to be 500 cosine 25, 500 sine 25, correct?
To get the, yes.
In component form, right? That's what we're looking for. Okay, so that's that.
Agree.
Flip the page. Let's go to example number 8. This is a little interesting. Example number 8, we have a,
Mr. Owen,
yes.
at the top of 462 for the example we just did,
Uh-huh.
why is there I and J?
We just talked about that.
Yeah.
You can use I and J, right? It's the same thing. But in the end, it comes back to what I just have on the board, right?
Okay. Yeah, right.
It's, again, it's another form of expressing the same data without using the brackets.
Okay,
Okay, does that make sense?
somewhat.
Okay.
Sure. I'll just move with it.
Okay, so example number 8. Pilot Megan McCarty is flight plan has her leaving San Francisco International Airport, flying a Boeing 727 due east. So the flight plan says you have to go due east. There's a 65 mile per hour wind with a bearing of 60 degrees. Again, that word bearing. Find the compass heading McCarty should follow to determine what the airplane ground speed will be, assuming that its speed with no wind is 415 miles per hour. So I have a wind at bearing of 60 degrees of 65 miles per hour. Okay, so from here, we go 60 degrees. Like that. So this is going to be 65 miles per hour with this angle being what? 30 degrees, exactly. So I'm going to fly a plane. This plane needs to be going due east. It needs to be going this way, straight, due east. So when I add the two vectors, this plus the plane, right? They have to be going directly due east. So the plane's going to be in which quadrant?
East.
There's no quadrant called east.
4.
4, right? It has to be 4, right? If you think about it, you're going to have, because it's much greater than that, it's 450, right? In other words, you want the force that is pushing this guy up be canceled out with the force of this guy going down.
Oh,
Does that make sense?
yes.
Because you want the end result to be like this. You want the end result to be straight. In other words, no y component. Are we good?
Somewhat.
Okay, so what we're trying to find is this guy. This is the guy we're trying to find, x. Okay? Because I know the magnitude, I just need to know the angle here. So the y component of this guy is what? Is it the sine or the cosine? It was a sine, right?
Yeah.
So 65 sine 30 is going to be equal to 450 sine x.
Oh.
Does that make sense?
Yeah.
Does that make sense?
I guess. That's it. Oh, that's much easier.
This guy is 1/2. Divide by 5, I get 1390. 13 over 180 sine x. Somebody do the arc sine for this for me. What do you get for x? Somebody get 4.14, I hope?
Yep.
Not today?
Well, the book says, negative 4.14.
Yeah, 4.14, right?
Negative.
Yeah, negative 4.14, because it's going from here down this way, right?
Yes.
So this guy is 4.14. So what's the bearing? Go back here, look up here. What's the bearing? You're gonna
94.1.
exactly. I start from here, go 90 degrees, and then 4.14 more. So the bearing is 94.14.
That's crazy.
Okay, so so there's several ways to screw this up on a test, right? You can get this guy is easy. Then from here to here, you could probably screw this up. But once you get this, then you have to be able to go ahead and say, okay, so the total bearing is this. So there's a few steps that you have to go through there, okay?
And we do partial credit.
What will we do without partial credit?
Yeah, I'll take this class.
Example 9. The last one, example 9. Finding the vector effect of gravity, force of 30 pounds just keeps the box from sliding down the ramp. And inclined at 20%, find the weight of the box. So I have a box here with a weight vector here. If I decompose this vector into 2,
I hated this.
so this one vector can be decomposed to this guy plus this guy. Does that make sense? Can you see that?
What about friction?
Let's just talk about the weight here. Okay, the weight vector, I'm going to decompose it into these two vectors at 90 degrees over here. Okay, so this guy was 20 degrees because this guy was 20 degrees, correct?
Yes.
So I don't know what the weight is. We'll call it W. Okay, so what is this guy going to be?
30.
30, right? Because the book tells us it's
Yeah,
30,
we
right?
agree.
It's 30, right? So this is 30, right? So in other words, the weight times sine of 20 is equal to 30. Does that make sense? Yeah, you see, just divide it out. You're good.
Do we not do the pushing force and stuff?
Okay, so is anybody taking physics next year? Nobody's taking physics?
Oh, yeah.
You take physics?
You take an AP or on.
Okay, so this is what we call, this is the force that's it's trying to fall back down here. And what's holding it from that is the friction force between this guy and the ramp. Because this guy and this guy is equal. The friction force is calculated as a mu n. Mu is this is a coefficient, friction of coefficient.
Then Newton, right?
And then n is the normal force. Normal as not abnormal. Normal as in being perpendicular or 90 degrees to the surface. So this guy here is the normal force because it is 90 degrees to this surface. Okay. So the friction force we are told is 30 here. And then the normal force here is going to be the weight cosine 20. Cosine 20. Right? But the weight here was what? Right? If I divide this out, I can put it in here. Mu 30 sine 20 times cosine 20. These cancel out. Mu is going to be equal to sine 20 over cosine 20, which is tangent 20 degrees. Just giving you a little bit of glimpse of what you will talk about in physics. It has nothing to do with pre-algebra, pre-calculus. Okay? Yeah.
Why don't you teach physics?
Why? I'll tell you why.